Start.
Good afternoon, everyone. My name is Parwinder Singh, and I am a student of A23-0623 College of Tertiary Studies. And this course is DC6013 Construction Management-2. And today I am representing the presentation title is a passive fire protection system meets in accordance with the requirements of structure and the New Zealand building code. And the next slide is the first we are representing the introduction. Passive fire protection for the purpose of the prevent fires and block them from developing without the need for active correction. Passive fire protection or PFP is an essential component of fire safety in building design. PFP is built into the building and is passive until a fire breaks out, opposite to active fire system like sprinklers or alarms. It depends on protecting buildings, soil foundation, safeguarding customers, and reducing damage in the event of a fire. Doors, dividing up systems, protective paints, and fire-resistant materials are key components of PFP. Together with each other, these items and limitations are key components of PFP. Together with each other, these item limitations, the development of heat, smoke, and fire, allowing crucial time for emergency, involvement, and getting away. PFP is essential for life safety as well as for verifying accordance to the construction rules and boosting a structure's resistance. And the next slide is, there are 5 types of key components of the passive fire protection system. The first one is fire damper, and the second one is fire doors and hardware, and third one is penetration and seals, and fourth is sprinkler system, and 5 is emergency egress. And the next slide is first fire damper introduction. Fire dampers are essential components of passive fire protection PFP systems designed to prevent the spread of fire and smoke through ductwork in heating, ventilation, and air conditioning HVAC system. They are installed where air ducts penetrate fire-rated walls, floors, or ceilings, ensuring that the building's fire resistance is maintained. In the event of fire, fire dampers are activated either by the melting of a thermal link or by a signal from a fire alarm system. Once activated, the damper's blades close, creating a barrier that restricts the passage of flames and smoke. This helps to compartmentalize building, limiting fire and smoke to the area of origin and providing more time for evacuation and fire lighting. Fire dampers are critical for maintaining both life safety and structural integrity in a building. They are commonly used in commercial, industrial, and residential settings, contributing to compliance with the fire safety regulations and enhancing the overall effectiveness of PFP systems. Ministry of Business, Innovation and Employment. Next slide. There are some common issues like poor installation reduces fire-rated barriers by creating gaps around the damper frame. The second is damper not closing because not mechanical issue, rusting or waste. And third is difficulties to access for maintenance and inspections. Recommendations: verify that fire dampers adhere to AS and ZS 1668 for smoke and fire control. Regular maintenance and inspection to confirm fitness and functionality. And NZBC compliance recommendation: install fire dampers in accordance with the AS and ZS 1668, making sure they satisfy the barriers or walls fire resistance standards. Use fire rated materials that have been tested to AS and ZS 1530 to seal the spaces surrounding dampers. In accordance with the clause C6, perform routine maintenance and inspection to guarantee correct alignment and operation. Provides access panels to so that testing and maintenance are simple. Ministry of Business, Innovation and Employment. Next slide. Second is fire doors and hardware. Introduction. Fire doors and their hardware are integral parts of passive fire protection system designed and to prevent the spread of fire and smoke within a building. These doors act as barriers maintaining the integrity of fire resistant compartments and protecting escape routes such as stair walls and corridors. Constructed from fire resistant materials, fire doors are as engineered to withstand fire for a specific duration. Example 30, 60 or 90 minutes. Essential hardware such as hygiene, hinges, closures, instrument seals and fire rated locks ensure the door performs effectively during a fire. Together they prevent the passage of flames, smoke and toxic gases, offering critical time for safe excavation and emergency response. As a concern of PFE system, fire doors and hardware play a vital role in preserving life safely, minimizing property damage and ensuring compliance with fire safety regulations. Next slide. And is the common issues like plumbing that is improper or broken causes doors to not close or self-close. Improper modifications including glass or ventilation getting addition reduce the fire resistance of the door. Use of door knobs and construction that are not certified. Penetration and seals. Penetration and seals are vital components of passive fire protection system designed to maintain the integrity of fire-rated walls, floors and ceilings when services like pipes, cables or ducts pass through them. And the next slide is, these are the common issues like penetration in fire-rated walls, floors and ceilings that are either poorly sealed or left open, such as around pipes, cables or ducts. Use of fire stopping products that have not been tested or certified. And the fourth is sprinkler system. Sprinkler systems are typically categorized as active fire protection systems. They play an important role in supporting the overall effectiveness of sprinkler system is a common issue. Sprinkler system and passive fire safety measures such as unnecessary opening in fire-rated walls are not properly integrated. Water sprinkler heads that are lost and damaged or blocked. Poor maintenance cause flow rated and temperature to fall short of design. And the NZBC compliance recommendation: install sprinkler system that adhere to NZS 144541, making sure they complement the building's fire safety plan. And the next slide is emergency egress. Emergency egress refers to the safe and efficient means by which occupants can exit a building during an emergency, such as a fire, earthquake, or other hazard situations. It encompasses all the physical pathways, systems, and protocols designed to facilitate the rapid excavation of individuals while minimizing risks. Key components of emergency egress include escape routes, doors, stairs, exit signs, and emergency lightings, all of which are carefully planned and designed according to safety codes and regulations. And the emergency egress, these are the common issues like obstructed or blocked exit options. Separation can be compromised when non-fire rated materials are used in stair walls or transit pathways. Weak exit notice or hazard lights. These are the NZBC compliance recommendations for a safe and easy evacuation. Keep exit routes clear and make sure they adhere to clause C4(3) in accordance. And the last is conclusion. Passive fire protection is vital for ensuring safety and structural integrity during a fire. It involves built-in measures like fire-resistant materials, fire doors, and compartmentalization designed to slow fire spread and provide safe evacuation routes. and these are the overall references. And thank you.
Could you please go to penetration and saving slide? Could you please show me what are the issues relevant to the penetration and saving industry?
These are the gaps in the gaps.
In order to become standard fire door, what are the two requirements for the New Zealand? To become a standard fire door according to the New Zealand building code, what are the two requirements